speaker is Dr. Yang-Fu Kuo from National Taiwan University. Yang-Fu received his PhD from Purdue University. I forgot to mention with Dr. Lin, his was Iowa State, so we're all kind of here in the Midwest for some of our degrees. His research includes machine vision and automation in agriculture, and today his talk is going to be on applications of machine vision in animal husbandry. Dr. Kuo.
Yes, give me a minute to. Oh, okay. So how about my slides?
There you go. It's starting to show up.
Yeah.
There you go. Thank you.
Yeah. Sorry, the screen looked complicated on my side, so I don't know how to do that. Thank you very much for the introduction. So I'm Yang-Fu from National Taiwan University, and today I'm going to share some experience. So the title is Applications of Machine Vision in Animal Husbandry. It's a little bit wide, big, but because I'm putting several independent topics here. So okay. So let's talk about why animal husbandry. We know that animal is actually the main protein source for human worldwide. And I'm not sure if this table is still valid since the tariff issues recently. But anyway, we will still raising animals at least for I can see that in the coming 10 or 20 years. And but animal raising is actually very laborious. We know that many farmers, they have to work for a long time in the farm, do many chores in either cow, chicken, or in pig farming. Those are the main economical animals worldwide. And so, and another issue that we face is that labor shortage. And in the lab, you can see that a chart that is the number of births in Taiwan, and it dropped from 400,000 to around like 130,000 recently. And so a drop of probably approximately 60 or 70%. And on the right-hand side, we can observe in the developed countries that the employee in agriculture is dropping too. And I think this is worldwide, especially for the developed countries. And so what we can do over here is machine vision. We use machine vision to replace what human beings need to do, and that will save the labors. And that's the like the point why I started to do this research. So I will give 3 topics. The first topic is about the monitoring of chickens in Taiwan. And we know that the chicken is a major protein source and still growing worldwide. And the chickens here I'm talking about is actually not broilers. Those are native chickens in Taiwan. And native chickens are very different from broilers. They need like 12 or 13 weeks to raise. And that's a long period of time. But the texture of the meat is very different from broilers. So for the domestic consumers, they like this kind of meat for like chicken soup cooking, etc. And this is also true for many countries in Asia. And another issue, I think it's the same in the United States, is the avian influenza. I know there are many like egg chickens. Those are killed because the disease. And we think that this disease is going to be an issue if it outbreaks like the COVID-19. So every time that we enter the chicken farm, we have to put protections. And that is actually a lot of work and also make you feel uncomfortable. So we try to prevent the frequencies that or the time that the farmer needs to go into the chicken farm. So some solution that we come up with is automatic monitoring and warning as also. So the basic idea is that we install some cameras in the chicken farm, and then we stream those videos to a cloud server, and we do some calculations, and I will explain the details later. And more than that, we come up with a web page or some SMS approach that can warn the farmers what is going on in the chicken farm, and only ask the farmer to go into the chicken farm when there's emergency. So what we are monitoring? We are monitoring dispersion and movement. So dispersion is actually like how the level spreading of the chickens. So in the very left-hand side, we can see there's a dispersion number of 0.4, and that means there's almost no chickens, very few chickens. And on the right-hand side, we can see a dispersion of 1.4, a high, relative high number, and that means it's crowded in that area. So this is only an area in the chicken farm. But if this area is crowded, that means in some areas there's no chickens. So that could be an issue. And another is the movement. So we use YOLO and some tracking algorithm. If I recall correctly, sort. So we know the movement of chickens. And so before we do anything, we have to model their behaviors. I mean, the dispersion and the movement using some principal models. So here we can see that the x-axis is the week. So we can see that the dispersion going up when the chicken grow, and that makes sense because when the chicken grows, they have the space between chickens is reducing. So basically, they have a narrow place to stay, so that causes the increase in dispersion. And once we know the model behavior, the long-term dispersion behavior, we can come up with a model. And here we use ARIMA. And so in the green zone, that's the 95 confidence interval zone. And in that zone, we say that it is totally okay. Farmers do not have to do anything. But there is a like red warning. That means the chickens stay there crowded for 2 hours, or there's no chicken in that area for 2 hours. Then there must be something wrong. And also, next we observe the chicken movement, and we can see that chicken movement, they drops a little bit down because it's like human beings. When we grow up, we don't move that much. We don't be that active. And also the behavior between winter and the summer is a little bit different. And so here in the chicken farm, we see one thing interesting. We see one event that the chickens running, because these are not boilers, they are native chickens, they are very active, but they are running there for 30 minutes. I mean, when I saw this video, I thought that I wouldn't run for 30 minutes nowadays at my age. So what was going on there? There must be something wrong. But we don't have enough information to know what is going on, but we know there's something wrong. So these are the chickens. Now let's move to the pig farming. And for pig farming, I believe Professor Angela Green has already mentioned about their main 3 stages: farrowing, and nursery, and finishing. Okay, so let's start from the farrowing. So we want to monitor what is going on in the farrowing house. And I skipped the intro. So basically, pharaoh is the state that the piglets stay with their mother, the soul, together. Okay, so what we want to concern, the major objective is the soul as well as the piglets, how they behave, how they are doing. So our method is that because for the pharaoh, it's a crate. Crate is a little space, very narrow. On the top back, we install camera, and also we stream the video back to cloud and do some calculations, and we'll see the results very soon. So first thing that we do is to understand the posture of the soul. And to do this, we have to use videos as the input for a classifier. So this is CRNN, basically a CNN cascade with a LSTM. And here we see 7 behaviors. So first is feeding and second is standing. And these are actually very hard to be distinguished using a static image. We need videos to do that. So that this is the key. And the fourth behavior is recumbency. That is something that we don't want to see. The reason is that recumbency is that the soul hides her nipple and doesn't want to feed the piglets. And that means the soul doesn't feel very comfortable. And also some important behavior like lactating. And we separated them into right and left for some reason. Okay, so these are the behaviors that we want to observe. But what do we do? What information we provide to the farmer? We don't provide those information because those are too details, and the farmer doesn't want them to know those details. They want to have a chart that tells them everything. So the scenario runs like this. Every morning when before the farmer goes into the farm, and the farmers can have a sheet like this. And it tells them what is going on in the previous day or the previous night. And they only have to pay attention on the crate that is some issues. So in this situation, we can see that grade 4 is very different. So the yellow part is the recumbency, and that indicates that the soul in grade 4 is feel very well. Okay, and I think this is obvious. I mean, too obvious to be observed by computer vision. The real key point is the marginal one. The marginal is the soul is doing recumbency for a long time, but not that long. But there is marginal, and maybe the farmers they themselves cannot observe the issue like grade 10. So after observing the mothers, next we observe the piglets. We track their activities. And this is doing like group tracking. We don't do individual tracking. It's too computational expensive. And as well, what we provide to the farmer is actually the chart they can observe at a glance. So here, obviously, we see grade 4. Again, when the soul is not doing well, the piglets are not doing well. For grade 10, we can see, all right, the piglets, they rest for almost 50% of the time. That's I call marginal. This is something that the farmers may not pay so much attention, considering that the farm may have like 100 crates, like how much time he or she can spend on each crate. So this is important. Now, after I finish the pharaoh, let's move to the nursery. For the nursery, well, we use very similar approaches that we can see. Instead, the camera is installed on the rooftop, and also stream the video and back to cloud server and to observe and quantify the numbers. So what we really care here in the nursery. So nursery is, if you recall the situation the first day, you go to school in either kindergarten or elementary school. The very first day, you see someone who is taller, bigger than you are. What do you think? You think scared, right? And that is what is happening here in the nursery. So what we concern is aggression, or say bullying. Okay, it occurs everywhere, not only in human society, but also in the piglet society. So there are some important behaviors too, like feeding and drinking. So we have a chart that shows what is happening in this crate for 30 days. And the aggression is in here in the bottom left. We can see that the aggression drops gradually, and that is a good sign. If we see something that is not what has a trend like this, we probably have to identify the pig that has some issue, I mean the bully pig, and separate it from the pen. And for the rest, like feeding, drinking, etc., they should go up, like something like this, after the piglets they adapt to the environment. And other than animals, we also do some applications in other fields, like for tomato. Here in the left, we see a tomato application that is for tomato disease identification. And we are now working on this one to send the output from the identification of machine vision to a RAG system with LLM to provide more information to farmers. And then in the middle, we can see some application in wood identification, and with a cell phone and a magnifier. And so we take a photo of the wood, the cross-section image of wood samples, and then we can identify what it is. And on the right-hand side, we see some underwater image, and that is in a shrimp farm, and that we can identify the behavior of shrimps. So this actually the research are conducted by my student, not myself. So here are my students, and these are my the companies or the sponsors. And what I actually do in the lab is not doing research, but I do coffees. So if you need a cup of coffee, please come to Taiwan and stop by my lab. And of course, I can treat you a good cup of latte. And this is my research. Thank you very much.
Thank you. Are there any questions? I don't see anything in the chat yet. Anyone would like to ask a question online? I have one back in the examples of, especially in the nursery, looking at multiple pigs seems a lot like almost like agent-based modeling. Have you ever tried to apply that to understand the differences in behaviors, or they look like a lot of individual agents that maybe some of these modeling techniques might explain why they're going to water or playing or different things like that. I don't know if that's a tool that can be used or not. It just occurred to me.
Well, actually, certainly that's one direction that we want to do in the future work. And now for the nursery, it's not complete yet. We are still working on this one. There are more behaviors. First, we have to identify like playing. Like piglets, usually they play either with each other, and that is more challenging because we have to identify if it's aggression or play, or they play use some toys like for the piglets. And so that's what we are doing right now. But for the next stage is probably something as Dr. Reed just mentioned, some agent model or some I would say it's time sequential model, because now I'm not doing time sequential. It's more computational, expensive. But I think that's something that we can do in the near future if we have enough computational power. Yeah.
So we have a question in the chat from National Taiwan University. What are the feasibility and limitations of implementing an automated detection system in commercial farms?
Well, that's a good one. Actually, I think the farrowing project is more, I would say, complete. Let me go back here. So, what I'm thinking here is actually a total solution monitoring system in farrowing house. And the farmers can install a camera on a crate, actually. And we can do some, say, not edge solution, I would say it's a fog solution. We stream all the cameras, their videos into one powerful computer with GPU in the farm. And then every day or every few hours, the computer gives the results of the observation on each crate for the past hours, few hours. And now we are doing only the after farrowing or after delivery because the sow and the piglets are there already. But we can do during the delivery or before the delivery, like to estimate. So it's not complete, but this can be something that be a solution for farmers to, so intelligent, so smart that tells them what is going on or what is going to be happen next, and that will save their their energy to they can concentrate their mind on something else. That's something that I can come up with.
Thank you. Is it possible to fuse additional sensors into tracking, such as, I think they mentioned in the chat, an IMU. So I'm thinking they must mean by putting other kinds of sensors on the pig.
Yeah, I think it is possible. It is just that, doing like multiple sensors or called sensor fusion is actually even more complicated. The graduate student have to, match them one by one. So I'm trying to find a solution, a balance between what we can do and also the workload of the students. But I believe that certainly that's something that we can do. There are many people that use these IMU sensors to do like individual behavior analysis, and mostly it's for like cow or adult pig because they are bigger and they are more mature, and we know they are more expensive, and we need to know their like individual behaviors. But machine vision, I know, well, maybe I'm not sure. Yeah, I think that's a solution, but I'm still thinking.
And in the case of piglet behavior analysis, how do you handle the occlusion or overlapping of animals in the video feed?
Yeah, occlusion occurs a lot. If we take the look, see the rail, say for the piglets, we can see rails over there. But as long as the video is clear enough, the issue there is that we have to wipe the camera, the lens, once in a while, say at least once per week. And they still need some labor, still need the farmers to help because it's underdeveloped now. But for now, for rail, like this thick of rail, and we are doing fine. We are doing fine. So occlusion mostly happens is that that heater over there in the bottom left corner. There's a heater lamp.
Seems like it does a pretty good job with occlusion, and you can see in the images on the left. It's handling them from a top view at least, right?
Right. The view is actually very important. The view. So we spend a lot of time like choosing the optimal view. Yeah.
Okay, we have two more questions. If an abnormality is detected, are there any measures to deal with it? So you're creating chart. Well, let's just leave it at that. You have an abnormality. things that aren't showing up in, I guess it's maybe possibility it's not in your classes of things you're looking for.
Yeah, that's a very good question. Actually, now this result is only on 10 crates. Now we are collecting results from hundreds of crates. And that is the next step. Like for the chicken application, I use like 95 confidence interval for like normal. And beyond those 95% is abnormal, so abnormality. I think from my definition, that could be something we use big data. We have enough data, and then we mine from the data to understand what is going on there. And we are still collecting a huge amount of data, and I believe we are heading to that direction too.
If on this chart here, if farmers see this, I mean, farmer has 5 or 10 crates and they come in the morning and see this, which of these charts cause them to be concerned? Or, how do they interpret where there could be an issue? Is there one of these crates that it seems more problematic than the others, or is it just different behaviors in different crates?
Yes, like the yellow part is recumbency, so we don't want the piglet to do recumbency a lot. Right. So that's one issue. And as the previous question, so if we see something like this, now we only provide a chart, but if we see something like this, we can actually provide a text and telling them, okay, now this is a warning. This is some abnormality behavior that you have put to pay more attention. And that can also connect to the RAG system that we have been talking about, that provide more information, some abilities. And if we have sensors like humidity, temperature sensors in the field, that we can even provide more precise information. There's a lot of things that we can do.
Okay, and last question. For multiple object tracking, what has been done to prevent ID switching?
Oh, that is too professional. I think the students are talking about this. So ID switching is actually occurred by the occlusion. Basically, when the piglet they go through the rail from one side to another, and like the computer vision algorithm may not know this is the same piglet. So that's ID switching. And currently, we are not dealing with that because we are calculating the total movement. In a sense, we only want to know like how active the piglets are by like calculating the distance they have moved in the past few hours.
Yeah.
But we want to do individual piglet tracking. That is Thomas Norton, professor in Leuven, Belgium, has been talking about that we have to deal with like the ID switch very carefully. So it depends on the object that we want to do. And that is something in my mind, but now I don't have a solution yet.
Yeah. Thank you very much, Dr. Koro.